when you hear Web3, many people think it is blockchain. The blockchain world is growing quickly and is associating itself with Web3 for good reasons. But there's more to Web3, and that's what I want to talk about today. And to talk about linked data, and to talk about the whole story of Web3, we kind of have to go back a little bit to the origins of the web. And so let's review how the internet has been evolving. In 1989, Tim Berners Lee co-invented the World Wide Web. And this revolutionized our access to information. Everything that was difficult to find before or took a lot more time became accessible with just a few clicks. And what he did is that basically you had these web pages with information on it, and then there would be hyperlinks. And if you click on the hyperlink, you go to another document which could live on an entirely different computer somewhere else. This was the real invention, and this was the beginning of the internet that we now know today. So if we fast forward 10 years, the Web 2.0 term was first coined. And the web was changing and revolutionized again how we revolutionize our lives. And this time it changed how we interact and how we exchange information with one another. Instead of just reading and browsing the web now became more social and much more interactive. However, as we now know, the Web 2.0 also became filled with internet giants that created walled gardens and that gathered as much data about you as they could. And each and every one of them tries to grab as much attention of the user as possible. Because in Web 2.0, the user is the product. And so, also around 1999, when Web 2.0 was just getting started, Tim Berners Lee, the inventor of the World Wide Web, said, I have a vision. I have a dream for the web in which computers become capable of analyzing all the data on the web. The content, the links, and the transactions between people and computers. And he also said this web would be part of Web 3.0. So let's talk a little bit and explore a little bit what he was talking about for Web 3.0. What was his vision? So like I said in the beginning, and still today, the web is made of documents that link to documents with hyperlinks. And this is great for us humans, right? We browse through the web and find whatever we want, going through all sorts of different places. But for computers, it's not so easy. They don't really know what's happening. They don't understand what all these links are. It's just a link, yeah, you click on it, I'll load that web page. But what is the relationship? Are you reading more about the topic? Are you going to a related item? Are you going to a parent category? What is the relation to where you're going from where you were? And so he said, we need links for data. Because what's happening right now is that developers just take lots of time to deconstruct these web pages so that they become computer readable, so that the computer understands what's happening. And so Tim Berners Lee said, we need links for data. We need to interlink and connect our data. And that's what we see here. So this is a graph where data is connected to each other. So just like before we had the web pages that link to web pages, this would be a node, an entry point, a data point, connecting to another data point that can live anywhere else. So let's say I have a personal blog. I will have a unique identifier, which you can see here in the semantic web. Everything has a URL. And so everything that would be about me, I'm using my URL. And if I go to Paris and I write a blog about this, I'm not just writing the word Paris, which could maybe mean Paris Hilton or the city Paris. And you need to make that up from the context, but the computer doesn't quite know yet. No, I would be using the unique URL of the city Paris. And anyone else who ever talks about the city Paris would use the same identifier. And this is how the data becomes interconnected, becomes one big graph of interconnected data across the globe. So for computers it looks like this. Computers can read it. For humans, it looks like a graph. So this is the vision of the semantic web, translated a little bit in my own words. First of all, we have good data standards, right? So everybody uses the right data standards so that we can interconnect our data. We're also opening our data, we're sharing our data with one another so that we can collaborate and that we can connect this data. And then it becomes like one global database. And to give you an example of what that could mean, if I were to look for the number of COVID cases in countries in Southeast Asia in the last week, or I would look for popular books in the 90s in a certain country, or I would look for the most traded coin today in Bali. If I type that into Google, Google has some answers, but not everything, and it usually then gives you just links to web pages where you have to hope that you can find the answer. In the semantic web, everything is one global database. So you search in natural language, and the semantic web understands what you're talking about, gives you back real data. You get the real data, which coins were traded today, what was the most popular coin today in Bali. And this is our own extended vision. You can have an interface which then visualizes that data in a meaningful way. So you can actually see the results, you get the data back, and you get meaningful results visualized. Next point is decentralized, so the data can live anywhere. Human and machine readable, like I already said, and this is great for AI. And to give you one more example, imagine all your apps that you're using today would be made with linked data, made with the semantic web. Rather than having to switch through your apps and use plugins to connect them, everything would be interconnected. You would have access to all that data from one point, and you can create all sorts of efficiencies. And two more points. So, self-sovereign data ownership, that means that I am owning my data. Right now, these internet giants are harvesting all our data, and you don't really own the data that you put on social media. They own it. In this web, you own your data and you control your data. And you can also choose, this last point, who do you share it with? Who gets access to what and under which circumstances? The reality is, however, that this semantic web has failed to become a full reality until this far. Perhaps that was because in the early 2000s, these internet giants, there was a gold rush of data, and they centralized it and controlled it. And this is kind of the opposite of open, interconnected data. Or perhaps it was because it was a very academic field. There's a lot of potential with interconnected data, also for AI. And so there's a lot of research being done, and therefore it's very academic. And that means there's a steep learning curve, and maybe not so many specialists. And so adoption was minimal for a long time. Then in 2006, Tim Berners Lee coined the term linked data. Rather than just talking about the semantic web, which is the whole vision, he said, this is linked data, and that's just the technology. So we got better standards for interconnecting and linking our data, and better tools, the technology has matured, and so adoption has been growing. Also schema.org came along, which was all the big search engines said, you know what, we can use some of this linked data. And they created a long list of data types that they invited everybody to use. So that if you create a web page and you're talking about movies, for example, they invite you to use the schema.org movie tag. And the reason these search engines made this is so that they can create more intelligent results. If you're looking for movies today, you're actually seeing pictures, you're seeing the actors, you're seeing all sorts of information. You don't necessarily have to go to web pages. This is the result of schema.org. 20% of the web pages today use schema.org. And even though that's not the majority, we could say the semantic web is slowly becoming a reality through this. However, to the benefit of Web2 players. And so, what you see here in the bottom, linked data has been growing. In 2007, there were a bunch of large data sets that were interconnected with each other. Today, it looks like this, literally thousands of large open data sets connected with each other. It's used in many places today. For example, it's used by governments, the United States, the EU. If they publish data, they publish it as open linked data. Several industries, like healthcare and information sciences, different science departments. And for example, recently with COVID, it was used quite a lot to find out what the best location is for a testing clinic and to assist in research. So basically what this does, it creates one large knowledge graph, one global database. And knowledge graphs are becoming very popular. 90% of the Fortune 100 companies either already has a knowledge graph or wants to build one. So you'll hear more about this in the coming years. And linked data is a knowledge graph. So this was the early state of Web3 with linked data. We have data standards, it's human and machine readable, it's good for AI. I will talk about that a little bit more later. It's open. However, especially in the early days, there were a few problems. It's not necessarily the case that this was not happening at all, but it could be improved. It wasn't adopted as much as people hoped. We need more linked data, more data structured in this way. This ownership and control of your data wasn't fully there. Security could be improved. Decentralization was kind of there, but also not fully. And Tim Berners Lee mentioned he had this vision of transactions between humans and computers. And I think that's kind of funny because we kind of know what's coming next in the story of Web3. And maybe you can guess what can help with some of these things and what came along. So in 2008, Bitcoin came to the world. Actually, since we're doing history, blockchain has been around since 1991. It's a data structure that came out of research, out of academic fields. And it was popularized in 2008 with the launch of Bitcoin. And so Bitcoin showed us that with a combination of ordered cryptography and computational decentralization, we can inject trust into exposed information in an open transactional environment. So it's a complex line, but it comes down to this. Bitcoin in one blow solved a whole bunch of things that were part of the original vision of Web3. Right? We have trust, it's open, anyone can see the blockchain, but it's very secure. It's definitely about transactions between humans with computers also. Decentralization, nailed that quite well. And then later on, Ethereum came along in 2013. And Ethereum introduced smart contracts. And you probably know about smart contracts, but they're just little programs running on the blockchain. And they show that we can automate the execution of certain agreements when predetermined conditions are met. And so this is perfect for what we want to do with data. Who can access data, who can change data, and under which circumstances. So as we now know, blockchain is becoming a big success. It's rising a lot. There's a lot of adoption. Everyone here has heard of it, and many people in the world have heard of it. And with blockchain, Web3 is revolutionizing once again our interaction and our access to the internet. And this time it's changing how we make agreements and how we exchange value. Yet, despite of the success that it has so far, there's also problems with blockchain. And in the root of its success and its adoption lies some of the biggest problems. And so I want to ask you before we go on, what are some of the problems in blockchain? Can anyone tell me what are problems today with blockchains?
Search.
Search, okay.
Usability, user experience in general, terrible,
Non-existent.
Yeah. Anything else?
Wealth distribution.
Wealth distribution, okay.
Greed.
Greed.
Manipulation.
Sorry?
Manipulation.
Manipulation, okay.
Connections with external events.
Right. So it sounds like there's some problems. And I want to specifically talk about the problem of search that was mentioned first. And what's related to that, something that some people call blockchain's data problem or query problem. So in the beginning, blockchain was mostly about transactions, right? It was about peer-to-peer banking. And it worked very well for this, but that requires very little data. And it became popular, and then projects came along, enterprises came along, and they wanted to build stuff on the blockchain. But for applications, you need sophisticated data storage and retrieval. And blockchain was simply not made for that, at least not in the beginning. And this got better over time, right? We have new blockchains now that kind of address many of these things with IPFS. But still, today, there's a limited scalability, and there's a limited amount of data that you can put on there. And especially search, that was a very good one. If you want to search across multiple bits of data and combine bits of data, it's terrible for that. It's really, the performance is really slow. And so, therefore, people that want to create decentralized applications when developers want to create decentralized applications, there's this big overhead to trying to do everything on the blockchain. And instead, they often resort to traditional databases. And this is what we call off-chain data. And so we have some things on the blockchain, but some things still decentralized, centralized. So that's hurting the decentralization part. And it also adds complexity. And even though this problem is worked on quite well, there's still another problem, which is interoperability. You may have heard this term, and it kind of means that things just work together. And we have this between blockchains, but also on apps that run on the blockchain. So between blockchains means that you cannot just move a token from one blockchain to another one. And we are solving this with like wrap tokens and bridges, again, extra complexity, because natively it just doesn't work together out of the box. But most of all, I want to focus on cross-app interoperability. And what that means is that basically what we're doing in Web3 today, and the blockchain world today, people create decentralized applications, but it's still very much the same as in Web 2. Everyone is coming up with their own structures for their information. And that's how the world works also today. And what that means is that if I want to start exchanging some data with you, if you have a project on the blockchain, then I need to understand what you're doing. And I need to, you have an API, okay, I look at your API. How can I get the data that I want from you? And once I have it, I then need to convert it to whatever I'm doing. And you need to do the same for you. And so that's a lot of work. Things don't just work together out of the box between applications, unless people put a lot of work into collaboration. And so off-chain data and interoperability remain some main challenges in blockchain in the coming years. Now luckily there's more to Web3 than just blockchain and the semantic web. And so this is the whole family of Web3 technologies that often gets mentioned. Somebody mentioned IoT, which was very good. Virtual reality and the metaverse often get mentioned in Web3. Also artificial intelligence, even though it's not completely new, it's been around for a while, it is mentioned as a part of Web3. Through some of these technologies and what they add to this vision of what Web3 can become. We've seen blockchain, and next is artificial intelligence. Well, obviously it adds smartness to the web. And it's also, it can reduce the amount of human interaction that is required for certain tasks, which is a good thing sometimes. However, the problem with artificial intelligence today is that it's not fully transparent. Machine learning and neural networks are basically black boxes. We know what's going in. We train it very well to know what's coming out. But in between there, these neural networks, it's like clever chaos. And we don't know exactly what's going on, and we cannot fully trust that the outcome is what we want, nor do we know why or how the intelligence came up with that. So it's not fully transparent, and can we really trust it is an open question. Internet of Things has been rising and is growing, and what this is adding is that it's generating lots of machine-readable data, which is good, we want that. But now it's not always human readable. And it adds this connection to the physical world. So if we're going to get a metaverse and we're going to be in the metaverse, it's also nice that it's connected, not just virtual, but connected to the real world. Right? So Internet of Things is helping Web3 to be connected to the physical world around us. And there's a lot of standards, some good ones, but some are very corporate or made in people's own interest. And it gets a bit of a mess, it's not very clear. And so interoperability is also a problem in the Internet of Things, things working together. Finally, virtual reality. It's immersive. It brings an immersion. You can now really be in the web. We were never in Web 2, but now in Web 3 we can be in it, which is kind of cool. So it adds popularity. And maybe if we're talking about adoption, maybe something that's very cool can help, right, with adoption. At the same time, what else does it bring? Well, not much besides that, but it's cool. However, interoperability, again, because we have heard about this metaverse, and people say it's going to be an open one metaverse. There's not going to be many metaverses. But what's happening is we are creating already metaverse games, and these games maybe run on NFTs to purchase certain assets in the game. But it's the same problem again. These NFTs cannot be moved between games yet. Why? Because they don't have a shared data structure. And so whatever is arising today in metaverses is not interoperable yet, and thus creating very notable metaverses, we could say. And linked data we have looked at. And so if we zoom out a little bit and we look at this picture of Web3, we see a lot of green tick boxes that are very cool. There's a lot of cool stuff happening. But they all have problems, and that's because it's all developing very fast, and each in their own corner. And we're starting to see some of these things being interconnected with each other. But really, there is still an interoperability problem across the space. And that's hurting, there's still a data standards problem across the space. And that's hurting openness. Like I said, we're still creating our own individual data silos that are hard, and it's hard to collaborate. And it's also hurting interoperability. Many things are not working together out of the box. And so what we most need today is a way for everything to connect, for everything to come together, to be interconnected. And we need a place where we can come up with shared data structures. We need a way for everything to speak the same language, so to speak, the same vocabulary or ontology. And linked data can bring exactly that. So this is how linked data can solve in a nutshell. It can help solve interoperability. It's a W3C standard. It's been around for a long time. There's very mature tools these days. It can help create open data structures that can easily be shared. Before I said that I would have a URL and Paris would have a URL, but the whole structure of like, in a game if you have like certain assets and what properties they can have, all that can be shared with a single URL. So we can very easily share data structures with each other. And it's very universal. Why? Because it all comes down to a thing being connected to a thing. And then a certain property, a way I'm connected to something else. This is called a triple in semantic web. And it's so universal that everything can be converted to this data structure. Any structure that other projects are using can be converted to this. And that means it can be used in all environments. And like I said, it's human and machine readable, which is currently not always the case. That helps with trust in artificial intelligence, or just generally us knowing what's going on, and machines being able to do something with what we're doing. And it's made with decentralization and interoperability in mind. So here is the full picture of the web. The web is evolving, and me and my team, we like to use this analogy of a child that's growing up, a baby that's growing up. We talked about the whole history of the web. And so we like to use this analogy of a child growing up. If you take a 1-year-old child, this child is just taking in information, right? It's just observing, collecting, it's all a bit chaotic, but it's just taking the world in. It's just reading. It doesn't do much back yet, that's in the very beginning. A 2-year-old child, sometimes maybe you've heard of the terrible twos. Children start to cry a lot and throw up tantrums, and so it's not the best time, some say, when a child grows up. And I'd like to think that in the future, when we look back at the history of the Web 2.0 was not the best time with these corporate giants harvesting all our data. What a 2-year-old child cannot do yet so well is sharing what it has, tries to grab. And maybe around 3 years old, what a child learns to do is to share, right? And that's what the Web3 is doing with co-ownership. And a 3-year-old child learns to take ownership for their actions and to be responsible. So we're imbuing the web with some responsibility. And a 3-year-old child really learns how to use its words. So we can really have a proper conversation, right? The vocabulary grows. And this is what linked data is like. Shared vocabulary so that we can have meaningful exchange of information much more easily. And finally, by the time a child is 3 years old, you can start to instill some values in the child. And that's basically what we're doing with smart contracts. We're encoding our values in smart contracts. So we thought this was a pretty good analogy. So to sum it up, Web 3.0 was all these technologies that we looked at. And the qualities of Web 3 is that it's transparent, ubiquitous, decentralized, open, and secure. Ubiquitous meaning it's everywhere. It revolutionizes how we make agreements and exchange value, and it has the potential to create inclusive, collaboratively co-owned, socially responsible experiences. And that's a big shift from where we are today. And in Web3, you can read data, you can write data, just in like Web 2.0, but you can now also own. It's co-owned. So in conclusion of our history of the web, I hope you now have a better understanding of everything that the web is, and everything that Web 3 is and can become, and what the role of linked data in that is. So in the rest of this talk, I'm going to talk a little bit about what we are doing to help bring linked data to Web 3 and to help everything become more interconnected and interoperable. So we asked ourselves the question, how can we increase the adoption of linked data? There is a lack of awareness, there is still a pretty high learning curve, and we basically need a place where we can come up with shared data structures, a way to collaborate on what sort of information do we want to exchange. And it's also still hard to use those structures easily in existing technology stacks, so we need to change it. To make that easier. And so this is our solution. We call it linked. We are open sourcing a library, and we are creating an open community for everyone. You're creating your own knowledge graph. We're supporting people to create their own private knowledge graphs, basically, or for projects. And once you have your own knowledge graph, a lot of functionality becomes available. And first of all, you can search your knowledge graph in natural language, like I explained about in the beginning. So you can search across all these data sets that you've connected. And what you get back is real data, not links back to the document where you had it. No, you get the data back and it's visualized in a meaningful way by finding the best components. If it's about coins, there's already some visualizations, interface components available for coins. So if I'm searching coins, I'm getting back real data and it will show me visualizations of coins. But really what we're focusing on in the beginning is that you can visualize data and customize it. So you can drag these components that are available for your data structures. You can combine them easily and you can drag and drop entire applications. So we will make it very easy to create decentralized applications for Web3. And the really cool thing is that we can publish that anywhere. In the beginning we're focusing on mobile and on desktop. But the cool thing is that with linked data, everybody uses the same terms, right? So if we're talking about tokens, for example, since people here are familiar with that. Token has a certain ID. And maybe there's all sorts of different types of tokens, like non-fungible tokens and all sorts of different tokens. But they all point back to the original thing of token. So once one person comes along and creates a 3D visualization, a way to represent a token, any token, in the virtual reality,
then anyone that created an application in 2D now has an existing mapping to 3D space. So you create something in 2D, and just by the power of community, adding little bits of functionality, your application starts working in virtual reality. And not just virtual reality, it can also be smartwatches or smart fridges. So what can you really do with this? To give you one more example, let's say you're into blockchain stuff and you want to quickly visualize some interesting data in space. Maybe, like I said, what is the most traded coin today in Bali? So you're connecting certain blockchain data. It maps to these interface components, and you can click together and find the data that you want. And you can create a visualization of whatever you want to show in so much less time than what it would cost you today if you would need to develop it. And then you can publish it to the web. So we are releasing this as a freemium model so that anyone can use it. And also we're gonna, like next comes a panel about community spaces, right? About communities and about DAOs. And that's why I want to mention, we're also going to create community spaces for this application. So what that means is we are helping communities come up with what sort of data they want to manage and co-create their applications and even gather some funding. And so that's how communities will be able to create Web3 applications together. So this is what we are building. We are first of all building a no-code app builder. And that's really what we're focused on. We will be releasing the first versions in a couple of months or in the duration of this year. And I want to mention two more things, the extensions of this and where this can go. The first one is that, like I said, you can search all your data, both your private data and public data. So where we see this go is either an extension of this product or a separate product can become like a search engine for Web3 or a data gateway. One place where you can access all your information and control it, own it, and visualize it and search it. And finally, I've mentioned the connection between linked data and AI a few times. And it's actually really interesting because, like I said, AI right now is like a black box. However, it needs a lot of data, and linked data happens to be like a knowledge graph, happens to be the perfect input for machine learning, so they work very well together. But there's another type of AI that can come from linked data, and this is Semantic AI or linguistic AI. It's based on reasoning. It's fully transparent. It follows rules. And so, with lots of linked data, we see Semantu going into Semantic AI. And since we're talking about communities, I want to give you an example of what this could do. So let's say you're with a community of 20 people or 50 people or 100 people, and you want to make a decision together. It's actually not so easy. If you want to hear everybody's opinion on everything, and everybody needs to hear everyone's opinion, that's difficult. Also in real life, if people live in communities, they have talking circles. I don't know if you've been in talking circles plus 20 people, but they go on for a long time. It's difficult. And so what this kind of AI can do is it can listen to each and every single person, have a dialogue about a certain subject, listen to what this person thinks about it. And the Semantic AI just connects all the dots from the knowledge graph and creates a mind map of what you're saying and how the words are connected. And it does that for each and every single person. And so it can also create a collective mind map. So now we have a mind map of what the collective is thinking. And from this mind map, you can generate language so that you can interact with the collective knowledge. And so we can iterate this and come up with decisions together by communicating with what the collective is thinking. So this collective mind map can give you a real good summary of what everyone is thinking. So this works with small communities, but it works also with, it has potential to work with bigger communities, potentially even the whole of humanity. And so just wanted to leave you with that thought. Think of an AI that we can trust, that is transparent, and that can help us collectively make decisions together and self-organize. So with that, that's the end of this talk. Thanks for your attention. I want to mention quickly these 4 links, or 4 things. If you want to interact with us, if you want to collaborate in any way, there are several ways that you can do that. We are currently raising our first investment round. And so if you're interested in that, we have a deck that explains what we're doing in more detail. And you can go to this first link. The second link, donate, is for linked, is for the open community and the open source library that we're creating. And right now we are on Gitcoin. I don't know if you've heard of Gitcoin. That's where people that produce public goods can get funding. And the way it works is that the more donations we get, the more funding we get from a bigger pool of resources. And so if everyone here would be able to donate $1 on this link, we would actually get enough funding to help us by donating a single dollar. The next one, collaborate. We have several positions that we're looking for, or things that we need help with, from videographers to copywriters, and of course developers, and several others. So if you want to see if we can collaborate, go to this link. The last one, learn. If you want to learn more, like I said before, you want to learn more about what linked is, what this library is, can you use it in your project, go to this link or go to linked.org, and we'll be hosting free events in April. And that's all. Thanks for your time.
Web 2.0, mostly at first driven by hyperlinks, then by things like open schema, right? The owners of the data owned those, but then search engines like Google spent a lot of money building data centers in order to index that data and also provide interfaces between the people and the indexes, right? So we want to be decentralized, right? And you've got a semantic web, and that's all very good. But at some point, doesn't somebody still have to index the semantic web and provide an interface to it? And how does that, what does that look like in a decentralized world? Where do those indexes live? The scale, right?
Well, actually, linked data and all the technology behind it is something called SparkQL. So there's a query language that allows you to query from different data sets that live everywhere. So it's actually designed for that. Whether it's performant enough and whether you still need an index or not is an open question. If the technology gets good enough, you actually don't need the index. If you're going to create an index, yeah, I see your question there, and there is an open issue right now with Google giving answers to things, and so it takes away traffic from the website. And if we're getting interfaces that allow you to access all the information without needing to go to the websites, the question is really, are there still websites, or are we just publishing data and creating interface components? And where do people get rewarded? We talk about co-ownership. So if we can create interfaces, companies that are co-owned by all those who contribute the data, then that issue is resolved in a different way. And that's also what we're looking at. We want to reward anyone that creates data structures, that creates interface components, and we want to reward people for their data that they open. And open up probably part of our revenue stream to anyone who contributes to whatever is driving the problem. So that's the question.
Yeah, thank you.
Like, how is it actually capturing and abstracting between many occasions of many occurrences of a single concept, for instance? I mean, if it's a written text data, okay, that's pretty easy. Like, each time it sees the word whatsoever, it can turn into something else. But there's also a lot of, like, how does it capture the similarities, for instance? How does it capture the audio if it does capture it at all? Because the whole problem of the not being able to exhaust the ontological types is the biggest problem, basically. And I wonder if there's something to catch up, and if there's a promising technology available now around to.
So, if I understand your question correctly, you're saying people will have different versions of the same concept. And
for instance, if we're talking, if this is a Twitter space, and the way I pronounce the word is different than other people, but we want eventually to count the person and the system, how many times the word is spoken, basically. And that can be applied by different token types, different NFTs probably is the one thing. So the unique occurrences of quite similar things, and abstracting the similarities in a way that it captures as many as possible, because I think it is still not going to be exhaustive in that term. But like, is there anything that is certain?
So there's a lot of ontologies that have been created for linked data, a lot of vocabularies with the main ways in which concepts are related. Right? There's some really basic ones that are used a lot now. And something that was needed at some point was something called same as. This is the same as something else. Even though we have both come up with things for it, we later realized, oh, we're talking about the same thing. And so there's a way to point to each other and say, this is the same thing. And that's then calculated by the technology. It knows that that's all the same thing. However, you can still remain that uniqueness by using the term that you were using. For example, if the word was spelled different, maybe there's some extra meaning behind that, so you can still capture that specialized meaning while still pointing to the same underlying concept. And yeah, of course, there is a big challenge to map all the data and all the concepts that we use today in every language and in every domain. But there are tools available already today to point to each other and to connect that. And also different languages is accounted for, so that you can have all the different languages that a word occurs in point to the same concept.
And is there anything specific you can mention, a good example of a solution for these problems?
So there's something called OWL, O-W-L, which is an ontology that has same as. It's been created by W3C. But this is, if you're using linked data, then you can solve it with existing ontologies. I'm not sure about solutions for this problem outside the domain. I can tell you a few more links in linked data that can help with this. Thank you. Any other questions? It don't have to be as complex. It can also be something that you didn't understand.
So I saw in the presentation that we don't need any programming language skill anymore, so you can just basically visualize and create the language. Is that correct?
Yeah. So there's already a trend for what is called no-code app builders. So the question was, she saw in the presentation that we may not need programming language anymore to create applications. And there's already a trend happening now, because all these technologies that I showed you that are part of Web3, it's all pretty complex stuff. Blockchain, Internet of Things, artificial intelligence, like it's pretty hard for anyone to understand all the complexities. And so it takes a lot of time. And so we're abstracting complexity. And we're seeing a trend in what's called low-code builders or no-code app builders. Basically just a little bit of code or no code at all. The problem with no-code builders, where you don't have to code at all, is that in our experience they're still quite limited, quite restricted to what you can do. And we see a lot of potential for this technology to really give a lot of flexibility, to allow you to really do what you want, and whilst still automating so many things where you can just drag and drop. And so, yes, we are building an app builder in which you don't have to code and can drag together Web3 applications. And to take that one step further, is I see a future with this Semantic AI that you can speak to, and it understands what you're saying, and it creates the application for you without needing to click.
Can I already test it?
That you cannot test yet, no. The app builder.
In your website, and I don't find
Yeah. Yeah, we're just coming out with all this stuff. I've been working on this for like 11 years, and it's only recently that we are really gathering a team and starting to come out with these technologies.
So if I fill in the form early access, I get access to test the app.
For sure, yes.
How do you access this thing? Like you will access through a wallet or through Web2 or through an identity or
How do you access what?
your software,
Yeah.
the app creator, like you will serve through Web2 or you will need to be on a blockchain with a wallet or an identity like on the internet computer or whatever.
Yeah, good question. So the question is where is Semantu available?
Yeah.
So in the beginning, this will be a browser-based application. So just in your browser, it's a website that you go to. We may actually have a centralized version of it. It's just a website that you go to, but we're creating decentralized applications from that website. Eventually, we see it becoming more and more decentralized itself, where it becomes a fully decentralized application itself, which you can still access through your browser.
And it's going to be cross-chain, like fully cross-chain. Let's say I want to build an application that matches together something that is on, I don't know, Wikipedia, Ethereum, and Nina.
Yeah.
Okay, that will be possible.
Yeah, so it all depends on, that's just connecting different data sources. And that's why we're opening the community, because we want people to create, if one person creates a connection to a certain blockchain that we hadn't heard of yet, anyone can use that, right? And so we'll be creating a bunch of connections and we allow the community to connect more data sources. And so yes, you can import all of that to create one knowledge graph. And we either host the application result for you, and we'll be extending that to be able to host it in more decentralized ways in the blockchain itself.
For those of us dinosaurs who still write code, are you also publishing Node.js packages or some way to get to your technology from code?
Absolutely. So Linked is an open source library. It's written in JavaScript, TypeScript actually. We are using Node.js. So this library is now on NPM and on GitHub, but we're properly releasing it early next month. So if you sign up for the newsletter, you get updates. Was there any other question there? Right.
So it is going back to the same thing. Is it creating a copy of the represented data? So is there kind of a storage problem as well, even if it's distributed?
So it really depends on the source of truth. So where does the data live? In this picture, we have different data sources here, right? If it's a blockchain, then blockchain is the source of truth. And we will create a copy. And we will probably do that live, so we don't even create an index. So if you're querying, we will just go to blockchain, get the data, make it into linked data, connect it to whatever else you're doing and use it. So live conversion to linked data. But for other things, like Wikipedia is already completely available as linked data. And we can simply host that ourselves to make sure it's performant, and so we will host a copy. So there's different situations. And if you are creating your own data structures that don't come from outside in our builder, then that will be hosted by us. And in the beginning it's just us, and later on we will also open that up so that it can be hosted anywhere.
When you're saying with live data, does it allow also to compare in like temporally compare with its similar occurrences in the past, or it's just instant replicate of that blockchain data, let's say?
Yeah, it really depends on the use case. So we're going to have to explore this ourselves. Different solutions for different use cases. Sometimes you want to actually see the changes over time, and there's some really good solutions for that. And sometimes you will want the live data, live pooling. And other occasions, maybe it's not fast enough and we do need to create an index and keep it up to date.